Exercise contains two parts. One is about finding square roots by factorization, and the other one is about finding square root by uh, finding square roots by division. The two techniques are will be used, and for the starting, I will first explain you some very easy sort of questions. Then we will move towards slightly difficult levels. In the very first part, you will see that the first requirement for the factorization is that we should have such a term that should be uh, able to factorize in such a way that it should become a perfect square. So if it is a perfect square, then only then it can be we will be able to find a square root. So if you look at the very first question, you will see that first question 4x square minus 12x plus 9y square. It will be first factorized in the form of a perfect square. Like we will factorize it, and either you factorize it by midterm breaking, you factorize it by using completing square formula, or you want to find it by either way. In all the forms, you should get at least a perfect square at the end after the completion of the factorization. This is the first or an important requirement. Otherwise, we would not be able to find the square root. So in this expression, if I just give you some reference that how we have factorized this one, this expression is actually in the form of uh, a square, b square, uh, whole square formation. So if I just write it here, it will be a square plus, just to give you some idea of what sort of factorization is this, b square, and then this is equals to actually plus 2 times AB, or plus minus AB. You can either write 2 times AB or plus minus AB. This is equals to A minus B and its whole square. So this form of, because this is the simplest example, so that's why you can see that this will be used as a reference, right? So the whole expression 4x square is written as 2x whole square, 9y square is written as 3y whole square, minus 2 times a will be taken as 2x whole. 2x whole is in place of a, and b actually is in place of 3y. 3y is in place of b. So by using this formula, you will be able to completely write it as square of two terms, 2x minus 3y whole square. So the first procedure is to complete the square root, or is obviously convert the term in after the factorization into a perfect square. So you can see that this has become a perfect square. Once it is become a perfect square, then the next process is that we will write the square root of whole expression. Like the whole expression is 4x square minus 12xy plus 9y square, the original statement of the question. This will be written again at the end of the question. You will place a radical sign or a square root sign over it, and this perfect square will be equated to it. Okay? Like this one, 2x minus 3y whole square, then a square root sign will be right above it. And finally, in the last step, square and square root will be cancelled, a plus minus sign will be placed, you will get 2x minus 3y. This will be written as the simplest answer. This is the answer that we have to place a positive and negative sign. Always place a positive negative sign with these algebraic expressions. So this is how the question will be completed. In all the questions in which the factorization is required, at the end you have to place a plus minus sign, either for finding the square root. This is a compulsion. If you will not place plus minus sign, the marks will be deducted. If you move to the next question, which I feel that should be slightly little bit difficult. Like if you look at the exercise part number 4, this part number 4, this part number 4. So in part number 4, you will see that again it is actually the formation of a whole square, but this formation is written in such a way, because the terms are composite and they are bigger as compared to the simple expressions. So you can take up a plus b whole term as a single term. For example, this is x and 4 will be combined together. This all will be written like 2 4 is actually 2 square and a plus b whole square. This whole term is actually written as a in the formation of a whole square. In the first term written as a perfect square, 2 times a plus b whole square. Similarly, the last term 9a minus b is again written as a perfect square, like 3 times a minus b is whole square. And minus 2 is written for the arrangement of the perfect square, like you can see that minus 2 times 2ab is first term, 3 times a minus b is the second term, and then you will write it as arrangement of first term square, second term square, minus 2 times first into second term. This will generate a whole square. First term 2 times ab, a plus b, and 3 times a minus b. Both of these terms will be written as difference of whole square, difference of two terms and its whole square. First term is 2 times a plus b, this is the first term, and 3 times a minus b is written as 3 times a minus b. And once you will write it as a whole square, then this arrangement will be disappeared, because obviously whenever you write it as a whole square, any term which is used as a perfect square, like just telling you, like if it is x square plus y square, or plus or minus like 2xy and plus y square, this is equals to x minus y and its whole square. So you can, because question is already in the form of a's and b's, so I have written the reference as a, just to give you some idea that this is this form of as a reference sort of x square minus 2xy plus y square form. So this actually, the whole statement of the question will be converted as a whole square, but as a whole square of these two terms. First term will be 2 times a plus b, and the second will be 3 times a minus b, because there is a negative sign in between there, right here. So that's why this will become the whole square of difference, like as I mentioned, minus 2 times x minus xy. And you always keep it in your mind, and whenever you will write the whole square, this product term will not be written in this way in it. So it will become a perfect whole square, and after the perfect completion of the whole square, you will start multiplying the terms, like 2a plus 2b minus 3a plus 3b, and its whole square will be as it is. And after the subtraction, 2a minus 3a will become minus a, 2b plus 3b will become 5b, and just an arrangement, either you can write it as it is, or you can further simplify it like writing 5b minus a square first, and then the next term onward as in this way. So at the end of the question, once again you have to rewrite the whole statement of the question again with a radical sign over it, and then you will equate this term as a whole square that you just factorize it above. Right here, this one will be written as a whole square, then the radical sign and square root, this will be cancelled, you will place a plus minus sign, and 5b minus a is the answer, that is the square root of this whole expression. Okay, for the time being, I have explained you the two parts. Now ask me about these two problems, or the question you want to raise about these two type of questions. I will wait for 5 seconds, 10 seconds. If you want to ask anything about these type of questions, so please do ask me so that I can answer you, and then I will move ahead for the next question. You can open your mics, on your mics, and you can ask the question. Yes. Students, do you want to ask any question? You can unmute your mics. Meg, you want to ask anything? Meg, Zara.
सर इस एक्सरसाइज का पार्ट 2 भी समझा दे.
Exercise part 2 of question number 1.
जी.
Meg, this one. x square minus 1 plus 1 over 4x square. Is met.
जी सर यही बना.
This one, okay. The question is about it contains a fraction in fact, so that's why actually this is a one line arrangement again, but you will see that same sort of question. I would see that there is no difference uh, in the previous one and in this part, except that it is a fractional part or the question which contains a fraction, but the procedure will be applied exactly in the same way as we have done in the previous part. First term is written as a whole square, then the last term is again written as a whole square, 1 over 2x whole square form. And this one is actually in fact of that whenever you have to arrange the question according to the formula, you should keep the formula in your mind. You have to first arrange two perfect squares like x square and 1 over 2x whole square. These are the two perfect squares. So once you will put it into the formation of the formula, so what will you do, that you will write minus 2 yourself, then x as a first term, and the second term is 1 over 2x. You just have to get them multiplied all two terms with 2, because this is a formula requirement that you should have 2 times first and second term, and first and second term will always be within the perfect squares like x square. In x square, x is the first term and 1 over 2x is actually the second term, because these two terms are enclosed in the perfect squares. So you would write minus 2 x times 1 over 2x. So 2x and 2x will be cancelled, you will get back minus 1, but you don't have to cancel it, you just have to show it actually that we have arranged the statement according to this side of the formula. So once the terms are arranged according to this side of the formula, so then you will directly write it as, in the next step, in the very next step, you will write this is the whole square of first term minus second term and its whole square, like this one. First term was x and second term is 1 over 2x, its whole square will become like this one. So actually this is a one line arrangement. Once it is, the arrangement is done, then the rest of the procedure is as it is. You will equate the question square root of the statement of the question with the perfect square and the square root sign. Square root will be cancelled and plus minus sign will be there. Third part is very similar to the second part. Just for a moment, I want to just tell you that it is just arrangement, same sort of question as we have done right here. 1 over 16 is actually written as 1 over 4x whole square, and 1 over 36y square is written as 1 over 6y whole square. So first task is that you have to first arrange the two perfect squares like 1 over 4x and 1 over 6y, and these two terms are written as once it has been arranged, you will arrange the two perfect square. In the next step, you, instead of looking at this part which is normally very confusing, that what the student should do with this one, so instead of going to arrange to look at this part of the question, you should directly go for the perfect squares what is written inside the perfect squares. You just have to either look at the sign. If it is negative sign, you will write minus 2. If it is plus, then you will write plus 2. So in this question it is minus, so you should write minus 2. Then directly you should write whatever is enclosed in the squares, like 1 over 4x will be taken as first term and 1 over 6y will be taken as a second term. You just have to write this arrangement, minus 2 times a, this is a and this is b. Once it has been arranged, you will write directly as difference of whole square, 1 over 4x minus 1 over 6y is whole square. So this will give you the perfect square of whole expression, and finally you will get the answer. Now if you move a little bit ahead, these were the first 4 parts, which in fact I have explained all these parts to you. Just keep on revising. I also want to tell you that what is the 5th part. There is no difference in the part number 5 as well, but it just not more than that. First term in the numerator and the second term in the denominator, you have to proceed in the same way as you have done in the first 4 parts. You have to arrange a perfect square in the numerator. You can see that a square, b square and minus 2 times ab in the middle, and same is done for the denominator. Means that you will write it 9x4, it will be written as 3x square whole square, 2 times first term, second term, and 16y square will be written as 4y whole square. So in fact, whatever you have done in the first 4 parts, you can see that actually 2 parts are combined together in the form of fraction. You just have to arrange a perfect square in the numerator and a perfect square in the denominator. As you can see that this is the arrangement of the 2 perfect squares, one in the numerator and another in the denominator. and at the end you will completely write it as a whole square form instead of writing into square of numerator and denominator. This is combinedly taken as a whole square, which is a requirement of the question, and then this square root will be cancelled and you will get the answer. uh, the type of the question will be changed from part number 6 onward. These are important parts because first 5 parts you can see that are comparatively, uh, what I should say, in those parts you were just required to arrange the whole square by using the simple formula. Similar sort of questions are here, but part number 6, 7, 8 are more important as compared to the first 5 parts. In part number 6, you have to notice the shape of the question. I would recommend, if you have the textbook, please do see the shape of the question. Part number 6, part number 7, and what I feel, part number 6 and 7. 6 and 7 have identical shapes, they have identical sort of procedure, and they are more important as compared to the first 5 parts. So let me explain you that how to start these type of questions. So first task is that you should be able to identify the shape of the question. So if these are normally written like first term whole square minus 4 times x minus 1 over x. So because shape of the question is different, so you can do two things. Either you, first recommendation is that x plus 1 over x whole square is expanded. Either you can expand it or you can wait for some certain time. You can first keep the next term, that is normally the second term, which we rename as, or we put it equal to some other variable, like x minus 1 over x is labeled as a. This part will be taken as a, and then you have to find the value of what is written in the very first part of the question. Like you substituted x minus 1 over x equals to some letter a, but actually you will find the value of x plus 1 over x as well. So for that purpose, x minus 1 over x equals to a, which was substituted, you will find the value of this term or first term in terms of a as well. For that purpose, you will have to expand the square. So if you will expand the first term by using the formula of a plus b whole square, you will get 3 terms. First term square, this is second term square, plus 2 times first into second by expansion of the a plus b whole square. This will generate 3 terms till here, right here, and minus 4 times x minus 1 over x is right here as it is. Now you will see that once you will substitute the value of x minus 1 over x in this place, write it in this place. At the same time, if we little bit scroll it down, my task is that first of all I will find the value of first term, that is actually x square plus 1 over x square, its value in terms of a's, and then we will be able to find it. Like you can see that first we have expanded the first term. This was of the form it is a question. We have substituted, normally we substitute the second term. So we substitute the second term and we find the value of the first term in terms of second term. So second term is substituted as a. So my requirement is that I have to substitute something in place of this one. So the procedure is normally this one, that you expand the square as it is. You can see that it is expanded. Now you will substitute the value of x square plus 1 over x square in terms of a's, this part of the question. If I just highlight it, because this is the only part which I feel that this is this needs some sort of explanation. So just to give you some better idea that I'm talking about this part only. This part. So my requirement is that I want to get the value of this part in terms of this part. Now, when you will proceed the question, you will substitute x minus 1 over x equals to a, y, or z, or any other name which you can substitute in this part. Its square will be taken because we want to find this value, x square plus 1 over x square, and you cannot get the value of directly if you will not take the square of this one. So take the square, x minus 1 over x whole square equals to a square. So its square will be expanded by using the formula of a square plus b, a minus b whole square. It will generate 3 terms. So these three terms, 2 will be shifted on the other side. So you will see here that actually we have just calculated the value of this part. What is the equation number 1? So in equation number 1, if you go back, this is equation number 1. Now you will see that in this equation number 1, this value x square plus 1 over x will be substituted with this one, with this value. So a square plus 2 will be substituted right here in this circle or in place of this circle. So it will become a square plus 2. From this value I will substitute a square plus 2 in this value. So you can see that it is substituted 1 in equation number 1. So a square plus 2 is a value of x square plus 1 over x square plus 2 is as it is minus 4, and this whole part is taken as equals to a. So we have converted the whole expression actually in form of a quadratic equation. And in this quadratic equation you will see that, like this one, this quadratic equation once generated, the whole of the question is converted in the form of first 5 parts. Like in the first 5 parts we have seen the questions, that those who are sort of in this form. So these are once again you have to rearrange the term, then you have to generate a perfect whole square. So a minus 2 whole square is there, and then you will substitute the value of a, which was taken as x minus 1 over x. So because question was in terms of x only, it wasn't in form of a, so that's why we are substituting the values of uh, a in place of x minus 1 over x will be substituted right here, and you will at the end will see that it is actually a perfect square. So at the end you have to write the statement of the question again, and at the end you will see that the whole expression will become equals to a perfect square plus minus sign, and this is equals to x minus 1 over x minus 2 whole square form. So this is a statement of the question, or the end of the question, that you will get the answer like this one. And part number 7, which is very identical to part number 6, in the same part you have to find, as I'm telling you, that in the second part you have to substitute, like x plus 1 over x is equals to a, and this part is equals to a. As I told you that in these type of questions you have to substitute the second term, not the first term. So you always keep the second term as a substitution, like a or b or something like that. Now once again, once you will substitute the second term, then it is required to get the value of first term in terms of those values. So x plus 1 over x whole square is written as its whole square. So x plus 1 over x plus 2 equals to a square minus 2. So 2 will be shifted on the other side, and a square minus 2 whole square minus 4a whole square plus 12. This is actually what we have done. If you move a little bit back, we have substituted the value once it is squared, and we have obtained the value of x square plus 1 over x square. So keep it in your mind. So this is the value. If I just highlight it, this part, this one. Now it is a value of x square plus 1 over x square equals to a square minus 2. This value which is in the box, it will be substituted in equation number 1. If I move a little bit above, you will see that this is equation number 1. So in equation number 1, so you will see the values will be substituted right here, x square plus 1 over x square. Its value will be at this place. Whatever we have obtained in the box below, you will substitute right here, and x plus 1 over x will be substituted as a. So the whole term or the whole question, it will be converted into in terms of a's and b, in a's instead of x. So this whole question, the value is placed, you can see that in the statement there was a square above it. So the square will be as it is. Keep it in your mind. If you will not write the square, the question will be wrong. So you have to place the square sign as it is, because we have just substituted the value of x square plus 1 over x square. So once the value is substituted, and then you will expand the square. This expansion will generate three terms: first term, second term, and the third term. minus 4a square plus 12. So 2 into 2 will become 4a square. The simplification will give you another form which will be further factorized as a whole square. You can see that first term, second term are arranged and then become a perfect square. So once a perfect square is generated, so keep it in your mind that we should not forget that this one, which I'm just going to highlight, this one which is in equation number 2. Like what is in equation number 2? This is the value of a square. So this value of a square will be used, or it will be utilized like this one. This value of a square will be substituted at this part right here. Whatever is the oval form, this a square value is in equation number 2, which I'm just telling you that in the above part right here, this is like a square's value x square plus 1 over x square plus 2. This will be substituted right here in this place. You will substitute this value of a square from equation number 2. If I would write it here, you can see that from equation 2, value of a square. So the a square is substituted from equation number 2, which is I have encircled with or keep put it into the oval shape. Now once it is the value has been a square's value is x square plus 1 over x square. I have rewritten it once again here. So value of a square is substituted. 2 minus 2 will become, or 2 minus 4 will become minus 2. So it will become a perfect square. And once the perfect square is arranged, in the next step, what is the requirement that we will write the statement of the question again, and then you will take the square root sign over it, and this will give you the answer like this one. So it is the end of the question. Okay, now open your mics and ask me quickly what you want to ask about these two parts. These are important. They may be appearing as your lengthy questions in your board exams, or maybe sometime maybe as short questions as well. But these are relatively more important as compared to the previous two parts. Yes, please ask the question. Open your mics and you can ask. We are talking about.
सर पार्ट 7 में हम इक्वेशन को एक्सपैंड क्यों नहीं करते जिसने हमने पार्ट 6 में किया?
Okay. Part 7 expansion. The difference between part number 5 and part number 6 by shape is that if you look at the statement of the question, if you will expand the question in the very beginning, for example in the very first part, I would also recommend you that because you are getting a little bit confused at what we have done in part number 6, why we haven't done it in the beginning in part number 7. So my question is that this, or my explanation is regarding your question is that if you are saying this, and why we have expanded this part in the beginning and I have encircled it, I would recommend that if you will not perform this part, which I'm just going to highlight it, we have expanded the term from this part to this part right here. This part, this is expansion. Actually what we have done, that this part is done in the beginning of the question. Even you can do it after the substitution and then you proceed for the expansion, because you can see that, look, the question is that what we have substituted, we always substitute in second term first as a part of the procedure. So you cannot get the value of x plus 1 directly from x minus 1. So please understand. So that's why it was required to first expand it and then put the value of or substitute the value of x minus 1 over x. This is a slight difference between 6 part and 7 part. But if you move to part number 7, you can see that in part number 6 we have generated x square plus 1 over x square first. Fine. But if you move to part number 7, the statement of part number 7 just below it, in part number 7, just look at the question. If you look at the question, you will see that the first part is already a perfect square with x square plus 1 over x square. So that's why we have substituted the second term as I told you earlier, but we have expanded, or we have taken the square root and then we have directly put the value in this place, like we have just formed the value of x square plus 1 over x square a square minus 2. So there is slightly difference between the first part, sixth part, and the seventh part. In sixth part, the statement was that it was in the form of x plus 1 over x only, but in part number 7 it contains a perfect square of sum of squares x square plus 1 over x squares. So that's why, because of the difference of the question, I have done. But I would also say that, as I told you earlier, that you can what you can do, that in this part right here, which I have highlighted, like this part, instead of doing it in the very first step, you can do it even after the substitution. आप ये इधर नहीं करते हो, you can perform it right below somewhere. After the substitution, you can do it somewhere here. So I hope you can feel that the difference is very clear about it. That how to. Any other question related to these two parts, 6 and 7? Students, please ask me. Okay, obviously the requirement of written practice is still there. You will see the question and then you will perform the question as well. If I move a little bit ahead, you can see that in next two parts, that is part number 8 and part number 9, they are of same shape of question. Because I told you that first four parts are of some separate shape of question. Those are in form of perfect squares. 6 and 7 are different shape questions. 8 and 9 are also different shape of questions. So I'm just going to tell you that these are comparatively easier one as compared to 6 and 7. 8 and 9 are comparatively easier. So what is required in these part number 8 and 9 is this, that you will expand, you will factorize each term either by using whatever is written in this question. Normally the midterm breaking is used in part number 8 and part number 9. So each part, like x square plus 3x, is factorized by midterm breaking. This is what we have done here. This is because of the process of factorization by using midterm. It is midterm breaking being used for factorization. So the purpose is just to give you some idea that what we are going to do. In each part, we have started the midterm breaking. First part, second part, and third part, the process of factorization is done. And you will see that each bracket or each part will generate two factors each, like x plus 1, x plus 2, x plus 1, x plus 3. But you will see that each of a factor will actually multiply with same sort of term again, and they will become the perfect squares. So the whole statement of question will be converted into three perfect squares, and finally all these three perfect squares will group together in the form of a single term, and its whole square will be formed. And at the end you will rewrite the question again, place a square root sign over it, and you will get the answer. But I would say that at the end you were supposed to uh, put the statement of question right here as well, somewhere here, and then you will place a radical sign over it and you will get the answer with plus minus sign. Uh, the question is, if you look at the next question, same sort of question is there, part number 9. It is in terms of x. Same sort of work should be done. Like it is again midterm breaking. Parts may be, factorization process may be written in little bit different, look like different way, but actually this is the same has been done in part number 9. Each part is factorized into two factors, and then these two will become actually the perfect squares. X plus 7 will become 2 times, 2x minus 3 will become 2 times, and x plus 1 will become 2 times. So this will become a perfect square. So at the end, once again, you will write the square root sign and you will get the answers like this one. Okay, about part number 8 and 9, please ask any question if there are any queries, and we will move to the division process, or how to find the square root by division process. And the meeting is just going to close within next 2 minutes. So we will reconnect for the next part, or for the explanation of how to find the square root by division process. Please ask if there are any queries, or if you want to ask any question regarding part number, last two parts we have just discussed. But I feel these are quite easier as compared to part number 6 and 7. 8 and 9 are quite simple, quite easy. Okay, just for next part, if you don't want to ask anything, I would explain you that for division process. I will take some other part like this one. You will see that normally the five terms are written in the calculation of the square root by division method. Five terms are written. That is the shape of the question. I just scroll a little bit above. Like in this question, you will see that x4, 10x3, x square minus 60x plus 36. The first requirement is that there should be normally five terms, but in some parts there are six terms as well in your syllabus or in your curriculum. So uh, one more thing is that the term should be in a descending order. X4, x3, x2, x and without x. This is the compulsion for finding square root by perfect square. And one more thing you will notice that the first term and the last term will be perfect square. Like 36 is a perfect square of 6 and x4 is a perfect square of x square. So first and last will be the perfect squares and the terms will be arranged in a descending order. Fine. Then how to start the question? If we move for the procedure, first term will be this is called as division process, but actually this is not the division. Fine. Okay, I would explain you after we will reconnect. So please, you will reconnect with me after 1 minute, 1 or 2 minutes, and then we will proceed or continue with the same question, that how to find square root by division process.